In this video, we're going to talk about writing in LaTeX. So in Calculus 1, we talked about writing in a Sage worksheet using %MD cells, and we talk about using LaTeX commands to write certain math things by enclosing LaTeX commands in $signs and so on. This time, we're going to talk about writing LaTeX documents as text files. And so, there's no calculation here. This is not a Sage worksheet. This is actually, LaTeX is a typesetting program. It's a way for you to type mathematical documents and make them look nice. So this is what it looks like when you open a text file. And maybe I should say a little bit about what you'll see, the files you'll see here. We're looking at assignment 3, writing in LaTeX, and there's several different things that are not normally in your assignment folder. So the assignment is here in its own folder. The template I'll talk about later, and then right now I'm looking at the notes. And the reason I put those in separate folders, see all these gray files here. Now, when you first open this folder, you shouldn't see that. You should just see the things in blue. There's the map, and which shows up inside there. That's just an example. There's a PDF of the output, and then there is the actual text file itself, which is a little bit too low there. There it is. And this is what I'm actually going to look at today in this video. This is what you should open. And when you open this and it processes stuff, it produces all these gray files. They're sort of little, different parts of its processing. So you don't need to worry about those. You can kind of just ignore that gray stuff. But this is the thing you should be looking at right now. And when you do, there are 4 panes that open up. This is the input pane over here in the upper left. And this is where you actually type stuff. You type your LaTeX commands, you type your document, and then it produces a nice looking PDF. Over here, this is the output pane, and this is a preview of the PDF that is going to be produced. So this is what goes in, and this is what comes out. You can see the output is a nice formatted document with all sorts of nice looking stuff that you can do there. Down here, this is the error box, and if you have any sort of syntax errors in your input, then it will list them here and tell you where they are. There's also, in fact, why don't I just create an error? I'll just stick an extra line in here. I'll put x squared. Now that's supposed to produce an x with a little 2 above it. The problem here is, let's click save so that it runs it. The problem is that that's a math command, and so I need $signs around it for math mode. And that's what it tells me down here, missing $sign. So if I want that to work, now it actually did work. CoCalc is smart enough to recognize, I meant to have $signs there. So it did show up like it was supposed to. And but we should get rid of the error. We should put $signs there, and now it's correct and there's no errors. There might be some typesetting issues, or there might be some warnings. Warnings are not quite as bad as errors. Oftentimes it has something to do with spacing or something like that. Usually with a warning, it works, things show up, but it's just warning you might be some little issue. Sometime with errors, it might not actually work. Now in that case, an x squared actually did show up, because that error it was able to kind of figure out. But some errors it can't figure out, and so you need to deal with them before things will actually show up over here. Okay, so this one is where you can control how LaTeX processes this input. There's different ways, which you can see here, these different kinds of text. You don't really need to worry about this. This box you can probably ignore. In fact, you might want to just close it. If you hit this X, it'll go away, and it'll make the preview pane, or the output pane here, bigger. And so you might want to do that. Okay. Each of these panes has its own toolbar when it's the active pane. So right now my cursor is here, and so there's a toolbar. If I click over here, there's a toolbar for the output, and there's a toolbar here. So I want to briefly talk about those different toolbars and what they do. I'll start with this side, the output pane. Now this button is supposed to synchronize the two views. So wherever, notice when I scroll the output, the input doesn't move. Okay, these are two separate things. So you can be looking at one place in the preview, and you can be working somewhere else on the input. And if you want to move the input to match where you're looking, that's what this synchronized button is supposed to do. Now it worked yesterday, but this morning it's not working. So I click it and nothing happens. I don't know what happened here. So I don't know if that's just a little fluke of today. I know it worked yesterday. Another way you can do that is by double clicking on any place on the preview, and it automatically, see how it moves to subsection, basic formatting. That's what this is. The 1.4, that's created by the subsection command, and then the basic formatting is the heading of that subsection. So you can always double click anywhere in the preview, double click, and it will move the input to match. This synchronized button is supposed to do the same thing, but it's not working. Now this one has been working today. So if I go down here to somewhere in the input here, like section, math and LaTeX, you can see this section heading, and I hit this synchronized button, the little S-looking thing, it moves the preview to, actually it didn't move it quite the right place, but anyway, it was close. Okay, so that's what that button does. These buttons are for zooming, so this one makes it smaller, this one makes it bigger, this one fits it to the height of the page, this one fits it to the width of the page. I kind of like this setting the best. It's a little small right now because I'm recording this video, and so I'm only using part of my screen. If I had this on full screen, then this would look a lot nicer for me. It'd be bigger. Alright, so those are zooms. This thing controls what displays in this pane. So by default, the PDF preview shows up. You could change things around. If you want the source code to appear over here and you want the preview to appear on this left side, you could change it. And there's errors and warnings, build control. And then this PDF native, that actually opens the PDF document, not just the preview, and it kind of looks like a normal PDF viewer there. This thing is for splitting the view. So like this one will split the frame horizontally, so notice there's two now. So I could look here and say, okay, I want to see what's happening on, this is page 5, but I still want to compare that with here page 1. So I can look at two different parts at the same time, and so that might be handy. And of course this next button splits it side by side. This one takes up the whole window with this frame alone. It hides all the other frames, and you can look at just this thing. And then you can hide that. And this one will actually close this pane. Oh, there's a couple other buttons. They're not showing up because on my screen is, or my window here is too small for recording a video. But on your window, you should see these other two buttons. This is to download the PDF, and this is to print the PDF. They normally show up here, but because I have my window shrunk down to record it, there's not enough room. Okay, so that's the output pane. This is where you'll see the actual output of the stuff you produce. Okay, the input pane is where you actually type your document. Let's move it back there. And so you can see that I typed this subsection command, and I put input pane, and this is what it produces. So it converts these commands to nice looking text over here. The first button in this toolbar is the green Save button, and then there's the blue Time Travel button. Those are similar to what we have in Sage worksheets, so you already know about those. By default, when you push the Save button, well, right now it's already saved, but if I change something, this would turn green. So let's change something. So I put change something, and when you click it to save it, it automatically runs the LaTeX process to convert this to the new PDF. And notice how change something now showed up over here. And this next button, this is the build button, which might actually say build on yours if you have it bigger. If you push that, it does the same thing. It processes this input. And the reason there's two is you can actually change the settings, which maybe I will right now. If you go to your account settings, that's the one with the gear, not the one with the wrench. Here, let me go down. This is the settings particular to this project. That's not what we want. We want the account settings up here, and now I got to find where it is. Okay, there's this thing right here. See where it says build on save? Whenever you click save, it'll automatically build the LaTeX file. And you can turn that off if you want. And that means that when you push the save button, it will just save. And that actually might be kind of handy. I'm trying to decide myself whether I want that on or not. So if I do it now, and I say change something, it saves it, but it didn't actually process it. So the output hasn't changed. So here it is, and change something didn't show up. So it didn't change anything. You actually have to hit build. It's up to you which way you want to do it. So let me take that out. And when you hit build, it automatically saves. But when you hit save, by default it automatically builds, but you can turn that off if you want to. Okay. And then there's the synchronized button we saw. This button reformats your input to kind of match some sort of standard model that somebody came up with. I'm not sure exactly what that does. I haven't tried it. That's a new feature they just added, so I'm not going to push that button, but you can if you want to. There's other buttons, if there's space, that might appear. So I'm going to fill the whole screen with this. And this is an undo and a redo button. Here's a zoom in and out button. This is cut and copy and paste. And there's a find and replace and jump straight to a line. Notice that all these lines are numbered. And this is the help file. This allows you to change what shows up in this pane. And then of course this closes. This one resizes. So depending on how big your pane is, you might not see all the buttons. So I'm not seeing all the stuff here because of the size. Okay, and there's really no reason to change this error one. Probably you don't really nothing much going on here. If you don't need this error thing, you could just close it out and have more input showing up. So maybe I'll do that, and then we'll focus on what's here. Okay, so that's the basics of what you're looking at in the tech viewer when you open a tech file. Let's look at what's actually in this document now. So at the beginning, all this stuff at the start, this is called the preamble. This is where you get the document set up. This tells it what kind of document it is. This specifies the default font size at 12. It can be 10, 11, or 12. This line lets me adjust the margins. Now, this is not the normal way to change margins in LaTeX. It's actually a special add-on feature. That's why it has this use package geometry. You don't need to worry about that, but it's a way to make margins a little easier by just specifying top, bottom, left, and right. You can change those if you want. I have them set at 1 inch. This is where the title is specified. So you'll notice at the top there is this title, and then there is my name, that's the author, and then there's the date, so when I wrote these notes. So that all shows up here. This is where you input the title, author, and date. This is what actually produces it, this make title command. All right, so then there's this line about special packages I'm using. So I've added some add-on packages. Those are not necessary to do a basic LaTeX document, but they are necessary to do certain features that I have. So if you come across additional packages that you want to use, just put a comma here and type it in. You can add them right there. Okay, that's the end of the preamble. This begin document says, okay, the actual document is starting now. The setup is done. This command again is what adds the title. If you don't want the title, you can just delete this and the title will go away. And then I have this new command. You may remember from Calculus 1 the display style command. It's used in math mode to make it look bigger, and we'll see the difference later on. I got tired of typing display style all the time, so I made a shorter command, \ds for display style. And so this is how you define a new command. You can define new commands if you want to. to do lots of different things. So in my LaTeX documents, if you use my template, I have this command there, and you can use \ds instead of typing out display style if you want to. Okay, so that's the basic thing. So let's see, we're right here. Okay, we're now in section 1.3, organizing the document. If you have a long thing, you know, more than just a couple pages, like mine is like 20 pages or something, I want to organize it using sections and subsections and so on. That's what this is, a subsection heading, and that's from using this subsection command right here. You'll notice somewhere there was a section. Where was the section at? I guess I should go back up. Basics of LaTeX is the section. Notice the section just has a single number, and that, here it is, \section, and then curly brackets, and then whatever you want to have in that section heading. And when you do a subsection, like this one, notice that there's two numbers. There's the section number, 1, and then the subsection number, which is also 1, so that's 1.1. Here's a new subsection, so it's 1.2. It automatically numbers that. If I were to add another subsection right here in the middle between these two, it would renumber everything so that it was all in order. So you don't have to worry about numbering the stuff. It does that automatically. Notice also that this section is bigger than the subsection. It automatically formats the headings, resizes them, makes them bold so they stand out. So it does all that automatically as part of that section and subsection. If you need to go even lower than that, there's also a subsection, which is actually, there's one right here. And then below subsection, there's paragraph and then subparagraph. And that's as low as it goes. So that will help you organize the document using those commands. If you want to do things like italics and bold and underline, that's in this section. I won't go through all of these. You can see I have the commands written here, and then I have the code so you can see it. Be careful if you're copying from my input, because notice sometimes I want the actual LaTeX code to show up in the output so that you can actually read it in the PDF. This is what the code produces. This is the code itself. So if you copy from my input, the code actually shows up twice. Once to make it show up and once to actually do it. And that's what you see like in this line. This is the bold line right here. This is the code that actually displays right here. This is bold. This is the one that actually produces the this is bold right here. And the difference is this verb. That says, okay, don't actually process the stuff inside here, actually just display it verbatim. That's what it stands for. There's a section later on that talks about this verbatim command. So if you want to copy and paste from my input, that's fine, but don't copy this whole verb part. That will not make it actually work. It'll make it just print out the code. What you want is this part. So anyway, sorry for that confusion, but it's necessary so that I can actually have code show up over here in the output. All right, so there's various kind of underlines and strikeout and crossout and all that kind of fun stuff. Now, some of these might not work in math mode. Remember when you have $signs, that's math mode, and you got your math commands in there. Some of these things might not work in there. You can change the text size. Now, the text size is not changed with a command. It's changed with a declaration. They are slightly different. This is one of the most irritating things to me about LaTeX is the difference between commands and declarations. I'm not really sure why they exist, but this is what a declaration looks like. It has a curly bracket at the beginning, has a curly bracket at the end, and then this is the actual declaration, \huge, and it produces this thing. It's bigger. The curly brackets mark out the portion of text that you want to make huge. Compare that with what a command looks like. These are all commands. You put \, the command name, and then curly brackets after the command name, and then curly brackets at the end. With a declaration, the curly bracket actually comes before the declaration name, instead of after. I don't know why that is. I mean, maybe there's certain contexts where that makes sense, but it just irritates me. Anyway, that's life. So certain things are declarations, certain things are commands, and there's different ways you can resize things. You can make it tiny, small, large, large with a capital L, large with all caps, huge, huge with a capital H. This is, I think, an increasing order of size. You can play around with that if you want to resize things. Now remember, you don't have to use this resizing stuff with your section headings. That's automatic. Okay? Now, in addition to commands and declarations, there is a third way that LaTeX uses to do special things, and that's called the environment. And this is, centering is an example of an environment. There's not a center command. Instead, you put \begin and then curly brackets center. That begins the center environment. And then when you're done centering, you put \end curly brackets center. This ends the center environment. Everything between the begin and the end gets centered. It might be these 3 words like I have here. It might be 10 pages. Whatever you put between the begin and the end gets centered. Okay, so there's certain features of LaTeX where it's command format, certain features are declaration format, certain features are environment format. Sometimes there's multiple ones of those 3 that do the same thing, and sometimes there's only one, so it's kind of crazy, but you'll get used to it. So you'll have these notes, you can refer back and make sure you get the format set up correctly. Okay, here's some stuff about spacing. HSpace command does horizontal space, VSpace command does vertical space, so you can put space between things horizontally or vertically. Page break makes a new page. There's something about smart quotes. For whatever reason, the quotation mark on your keyboard is only used for end quotes. If you want the mark quotes at the beginning, so at the beginning quote, compare this. See, this is actually an end quote at the beginning. Both the beginning and end look the same. Here's the begin quote and the end quote. So that's kind of what we want. And if you use the quotation marks at the beginning and end, this is what you get. That's not what you want. Instead, to get this smart quote at the beginning, you use 2 backticks. See this? Backticks or back quote. It's on the same key as the tilde, next to the number 1 on my keyboard. It might depend a little bit on which kind of keyboard you have. Anyway, 2 backticks. It's not that big a deal. If you type a LaTeX document and I see an end quote at the beginning, I'm not going to fail you or anything. And it works the same with single quotes. In this section, I talk about making lists. So lists are actually an environment. So there's begin enumerate. Notice there's an end enumerate. That creates an enumerate environment. And so that creates a numbered list. You just mark each item with this \item and then space, and you type the things in your list. And then it produces a numbered list. If you want just bullet points, that's the itemized environment. And again, each item is marked with a \item, and you have a begin itemized and end itemized, and you get bullet points. You can also nest lists like this one, and notice automatically, so I have a begin enumerate, and then within that enumerate, there's another begin enumerate. That creates a nested list. It automatically formats it differently. So it starts here with numbers, and then the sublist, it uses letters. Now you can actually control what it uses here to number the lists. I talk about that here, how to change the item counters. If you're interested, you can read through that. Remember, whenever you have a begin, you need an end. Otherwise, you'll get an error showing up in your error window. There are certain symbols that are used in the input here for special things, like \, for example, is used to begin a command. Curly brackets are used all over the place. If you want those symbols to actually appear in the output, you need to usually put a \, in front of them. So $$ actually produces a $. The \ doesn't show up. If you want to actually, I don't know, do I have the one here where if you want a \, I can't remember now what the command is for a \ actually showing up. I'd have to look it up. It doesn't matter. So same with %. Percent sign is used to make a comment. it's similar to the pound sign in the Sage worksheet. So anything after a percent sign will be ignored. You know, if I go over here to my input and I put %, then this is now, notice how it changes color. This is now commented out, so this will not be processed. That would, if I actually ran this, which I'm not going to, this subsection would go away, and all these other ones would be renumbered. So if you want a percent sign to actually show up in your output, you have to put \%. Okay, so I have some discussion of that. Here's a section about the verbatim mode, and there's two ways to do that. You know, this is if you want actual LaTeX code to show up, or maybe if you're doing Sage code, you might do this too. \verb, and then I put absolute value markers, these vertical lines, and then whatever goes inside there is just verbatim produced. For some reason, you don't use curly brackets for this verb command. I don't know why, but it doesn't work. If you want longer portions of text in verbatim mode, especially if you have multiple lines, then instead of using this \verb command, you should use this verbatim environment. So here's begin verbatim, end verbatim, and there's all the stuff that's going to be displayed. So this is some Sage code. I don't want LaTeX to try to process that anyway. I want it to just come out just like this. And even the font is sort of more of a Sage looking font. It's not the nice font of the text. So anyway, verbatim mode if you want to display code. If you want to include a graphical file, I have some instructions here. This is where the campus map shows up. You can size it various ways. You can include PDFs, PNGs, or JPEG files, and so I'll let you read that. If you want to include a table, there's the tabular environment. It's a little complicated because after the begin tabular, there's this little extra bit, these curly brackets, and then this CC. This is what specifies how many columns the table has. Each letter that shows up here corresponds to one column. The C means that the column will be centered. Compare that down here. The L means the first column will be left justified, the second column will be centered, and the middle or the third column will be right justified. So that you put L, C, and R in here, whether you want left, right, or center, and you type as many of those as you want columns. So if you got 20 columns, you'll have 20 L's or C's or R's. That sets up the columns. The rows, you just type across as rows. So this is the first element in the first row, first column, and then the ampersand tells you that that cell is ended. And then grade will be the first row, second column. And then this double / says the row is done. And then so the next thing will come on the next row. And so I got John and 99 and Jane and 100. And you can put as many rows as you want. You just keep typing row stuff and it shows up there. Don't forget end tabular when you're done. And I have some additional examples about how you can put lines here. Here's horizontal line. You can also put vertical lines. You can do that between any two rows. You can put a horizontal line. Between any two columns, you can put a vertical line. It's up to you. Here's one where I got lines everywhere. So I'll let you read about that. Section 2 is about math and LaTeX. We did this in Calculus 1. So I'm not going to go through this again. If you need to review, go ahead and read it. You can go back to your Calculus 1 lesson. It's the very last lesson we did in Calculus 1. But I have discussion of typing fractions and square roots and other roots, limits, derivatives, summation notation, integrals, and miscellaneous math symbols like the approximately equal to symbol, or Greek letters, or greater than or equal to, or less than or equal to, things like that. I also have some special things like this one. If you need to cancel, there's a little thing that lets you cancel and stuff like that. I also have some discussion of resizing parentheses. This is if you just type the parenthesis by itself, this is the normal size parenthesis, but I got this big fraction inside, so it doesn't look very nice. It'd look a lot better if I made the parentheses bigger so that the parentheses cover the whole thing. And I have instructions on how to do that. And you don't have to be parentheses. You can use different things. In fact, the left and the right side don't even have to be the same symbol. So I have some discussion of that. If you want text within your math mode, I have discussion of that. If you have some complicated math thing in a Sage worksheet, you can easily convert it to LaTeX using the LaTeX command. Okay, so this LaTeX command is in the Sage worksheet. It's not here in this LaTeX document. That's why there's no backslash in front of it. So if you have a Sage worksheet, you put LaTeX in an input cell and then put any sort of math inside there, then it will spit out the LaTeX command for that. So here, like I put LaTeX 3/4, and it gave me backslash frac 3/4. That's the fraction 3/4. And remember, when you copy it to LaTeX, you'll need to put $signs around this because this is math stuff. But if you don't want to type all the LaTeX code for some complicated formula, you can get it in a Sage worksheet and have Sage convert it to LaTeX for you. Okay, section 3. This is sort of the reverse of what we did in Calc 1. In Calc 1, we put LaTeX into Sage. Now here, we can put Sage into LaTeX. And rather than going to a Sage worksheet and processing and figuring it out and then like copying and pasting back into your LaTeX document, I mean, you can do that. And sometimes maybe that's easier. But you can actually type Sage commands right into your LaTeX document, and it will process the Sage commands and then give you the output. So here's some examples. If I want to calculate 2 plus 2, I say \Sage, curly brackets, 2 plus 2, and it will ask Sage what's 2 plus 2, and then 4 will come out, and that's what will show up. And so I have some examples of that. Obviously, 2 plus 2 would be a waste of time. But anyway, I also talk about how to make graphs. So that's \Sage plot, and then you can control the size. That's what this width is, and then curly brackets, and then here's the regular plot command. Inside this Sage plot command in LaTeX, you put the Sage worksheet, the regular old plot command, and then whatever goes inside this parenthesis, it's just like a Sage worksheet now, this plot command. So here I have an Xmin and Xmax. I changed the color, and so now I have this nice little salmon colored graph. So any plot you can do in Sage, you can bring into your LaTeX automatically by using the Sage plot command, rather than going into Sage, plotting it, copying this picture, and then using include graphics to paste it in. And sometimes the picture that Sage produces might not be the right format anyway, so sometimes you have to convert from whatever format Sage produced to make it something that LaTeX can use, and that's a huge headache. So simpler if you just use Sage plot. Now, this section talks about if you want to tell Sage information, like here I am telling Sage that here, define a function f, define a function g, define a function h, and then you can use those afterwards. So that's what this Sage block command is for. Sage block feeds this input to Sage, and it writes it out in your LaTeX document. There's also Sage silent, which feeds this input to Sage, but doesn't actually output anything. So it just sends this over to Sage. Now Sage has a k function in it, and now you can use the k function. If you want to, for example, calculate k of 4, you can just say \Sage, curly brackets, k of 4, and it will calculate it because Sage knows what k is. You've already defined it. Okay, so Sage block and Sage silent are used for inputting things into Sage behind the scenes, and \Sage is using for getting output from Sage and then putting it here in your LaTeX document. And then, of course, if you want to graph, there's Sage plot. So that's the different options of getting Sage in there. Okay, now when you're ready to write your own LaTeX document, I've included a template that has the preamble already set up, so you don't have to worry about that. I would suggest that you create a new folder for whatever LaTeX document you want. Remember, I showed you when you process a text file, it creates all these auxiliary files, all this gray stuff, and you don't want to, just make a mess of your normal regular folder. So, so I would suggest you make a new folder for each LaTeX document, and then copy the template. Go over here to the template. Where is that? Here's the template folder. So here's my template. You just click on this box, and one of these buttons is copy. Normally it says copy. Which one is it? Anyway, maybe it's that one. Mine's too small to have the actual written out labels, but there's one of these buttons that says copy, and then you can paste it into whatever folder that you created, and go into that new folder. I would suggest you rename the template to something more sensible. Leave the template there in its own folder so it's ready for use later on. Okay, your assignment today, you will go into the assignment folder, and you should open up this tex file. That's where you're actually going to work in your assignment. I won't do it because I don't want all those extra gray files to show up. But what you want to do is make these things in this goal. I gave you this PDF. You want all of this stuff to show up in your assignment file. And there's some instructions in there, so I'll let you read that, and let me know if you got any questions about that. We'll also have a group assignment, which is a writing assignment. You're going to write that entirely in LaTex. I'll talk about that more in class, but that's also something you'll need to do. If you need more help, pretty much anything question you have about LaTex, if you just go to Google and say LaTex and then whatever, like if you want to know about making a table, got LaTex table, you'll probably see many different helpful hints about doing tables in LaTex. If you might also look at this YouTube videos that a guy made using LaTex in CoCalc. They're a little bit old. CoCalc used to be called Sage Math Cloud. The name changed a little while ago. So he talks about Sage Math Cloud, but same thing as CoCalc. The LaTex editor also changed recently. And so, well, if you're watching this in June 2018, it's recent. Otherwise, it would be later. So it was May 2018. The LaTex editor was changed. So it looks slightly different. The toolbar is different. Those other two panes that I already closed, those weren't there before. So anyway, it looks slightly different there, but it still has some helpful stuff about different topics in LaTex, so you can watch that. All right, and let me know. I know this is really complicated, but it's really handy to be able to produce nice-looking documents with complicated math symbols. In Microsoft Word, it's just often difficult to make it formatted the way you like, and LaTex gives you complete control. So enjoy.